Alright, we are looking at topic 1.3. Topic 1.3 is talking about angles. Alright, on the topic of angles, I guess we need to start off first by defining what they are. Alright, so an angle is, first thing on your paper, an angle is formed by two rays. That have the same end point. Alright, so look at that picture right there. These two rays, we've got one that goes up like that, ray AB, and one that goes off to the side this way, ray AC, are the two rays that form this angle. Those rays that we just marked, those rays are the sides of the angle, and the end point is what we call the vertex of the angle. Alright, so in this diagram right here, the two sides would be ray AB and ray AC. The vertex is that end point that they have in common. That would be A, the point A. Alright, when you are naming an angle, there are a couple of different ways you can do it. One of them is by its vertex. You can call this angle A. I want to take a quick note on the notation right here, okay? This symbol right here that you're seeing in front of it looks like a squashed L. Okay, what that is a symbol for angle. So when you see something like this, angle A, that right there is actually said, when you read that out loud, it says angle A. Okay, it looks like a squashed L. It's kind of almost a greater than, kind of almost a less than symbol. Angle A. Okay. The other way you can name it that's also very common is by going through points that are on that angle. Okay. And so if you were tracing this angle with your pencil, you would name it by the order that you run into those points. So if I start up here, I would run into angle B, and then A, and then C. Or I could go backwards. I could do the exact same thing going backwards and run into angle C, angle A, and then angle B up there. Okay? You'll notice that in both of those, the vertex is in the middle. Okay? That's how it's supposed to be. Whenever you're naming it by points, the vertex is the one that goes in the middle. The last one is much less common. Angle 1, you can give it its own label and label it as a number. That's much less common. These two, naming it by the vertex and naming it by points, those are much more common. Okay, so we want to talk next about protractors. Protractors are tools, and they're used to measure angles. Okay? So look at this angle that's on here. We have one ray that's kind of blue-greenish that shoots off to the right. We've got one ray that's orange. It goes kind of up and up diagonally, okay? If we rotate that around, that's the exact same orange arrow, but because it's in different directions, it makes a completely different angle. Okay, and what happens is a protractor measures that rotation. What it measures is how far apart those rays are from each other. Okay, how far apart they've been rotated from each other. So the unit that angles are measured is in degrees. The unit is degrees, and it ranges from 0 to 180. There is a time in the future when we'll talk about larger than 180, but today is not that day. We're not worried about that right now. When you are using a protractor, first line up the bottom of the protractor with one of the rays. When you do that, make sure that the center of the protractor is over the vertex. And then the second ray will be pointing to the angle measure. What I have right here is an example of that. It's a virtual protractor that somebody made up, okay? we see right here, I'm hoping I can draw. Okay, well, I can't draw, but that's okay. We see right about there that the point, the vertex of this angle is in the center of the protractor. And we see that off to the left, right over here, off to the left, that ray goes through the 0 that's on the top row. You see it going across, going up and down right there? There are, going up and down right there, there across the edge of the protractor, there are 2 rows of numbers. The ray to the left goes through the 0 that's on the top row. And so when we move this ray around, when we move that ray around, it changes the angle measure, and it's going by the top row of numbers. You see how that ray AB is going through the top row 70? Well, it tells us that's a 70-degree angle right there. Okay, we bring it all around here. That's a 160-degree angle. Okay, but look at what happens when I move this one to the other side. Now we have it where our ray that's in line on the bottom, it's going through a 0 on the right side. The 0 on the right side is on the lower row of numbers. So we didn't even move this thing from where it was a minute ago. It's still in the same position, but now our angle measure is 20 instead of 160. Okay, and that's because this protractor goes by wherever your bottom one is. Okay, you always want the ray that's in line with the bottom of the protractor to be going through a 0. And then you can just count up instead of having to go at 180 and count down and find the difference. Okay? So when we go back to our PowerPoint here, when we go back to this, we have 2 examples, and they're kind of hard to see on your paper, and I apologize for that. But what we have right here is we have the ray across the bottom. It's going to this 0 right here. That's on the lower row of numbers. Okay, so we're not even concerned about what any of these are. We're not worried about them. We are only worried about the lower row of numbers. Okay, we don't need any of those. We are looking in between 50 and 60, and we are 1 tick mark above 55. So that right there would be 56 degrees. On this problem right here, we are looking at where this ray off to the left goes through the 0 right there. It's on the upper row of numbers. What that means is we are not worried about any of these. We do not care what those numbers are. We're not dealing with them. We're dealing with the 0 that's on top. So that tells us this angle goes right through that right there. And that would be 110 degrees. Okay, the question that comes up on the left side of your paper, I'm just going to talk for a second here because I don't have a picture of it on the slideshow. The question on the left side of your paper, how could you find the measure of an angle when neither ray is lined up with the bottom? Okay, so let's go back for a second and think about what an angle is. When you measure an angle, you're measuring how far one ray has been rotated. Okay? You're measuring how far apart the 2 rays are from each other. You're looking for the difference in their rotation. If you're looking for a difference, there's only one thing that you would do. If you're looking for a difference, you subtract. So when I look at that picture on your notes, there is 1 ray that goes through 110 and 1 ray that goes through 45. And the difference between 110 and 45 is found by subtracting it. All right? So to answer that question, how could you find the measure of an angle when neither ray is lined up? Subtract. All right, the next couple things of information is stuff that you learned probably in 4th or 5th grade. All right? Acute angles. They're little small angles that look like that. The way I learned it in 4th grade from Miss Duncan, my 4th grade teacher, she said that acute angles are the little small cute ones. Okay, so on your paper, I want you to draw an acute angle that's going to look about like that. It's a little small one. It is smaller than 90 degrees. Up next, we have right angles. Right angles have exactly 90 degrees, okay? Every single class that I teach this to has known, somebody has shouted it out before I even finish asking the question. A right angle has 90 degrees. Right angles are all over the place because they are aesthetically pleasing. There's something in human psychology that just really likes a good set of right angles. Okay, they're very, very sharp and very organized, and so they're everywhere. Okay, a right angle looks like this. I want to draw your attention to this little square thing right here. Okay, there are a lot of times in geometry. We've talked about this before. There are a lot of times in geometry where the math doesn't necessarily match the picture. Okay, there are some problems that will give you a picture of an angle that kind of looks like it might be a right angle. But if it doesn't have that square down in the corner, you cannot make that assumption. Okay? If it doesn't have that square down in the corner, you have to still do all the math and figure out what the measure of that angle is. You cannot assume that it's going to be 90 degrees unless it has that square. Up next would be obtuse angles. Obtuse angles are the great big large ones. The way I learned it in Miss Duncan's 4th grade class was that obtuse angles are obese. So you've got cute little angles, and you've got great big obese angles. All right, and that's what, that would be more than 90 degrees. The last one we're talking about, okay, also draw a nice little picture of an obtuse angle on your paper. It'll look about like that. The last thing we're going to talk about would be straight angles. Straight angles are what happens when you have 180 degrees exactly. Okay, a straight angle is what happens also when you have something we talked about a couple of lessons ago. Opposite rays create a straight angle. Opposite rays, remember, when you put them together, it makes a straight line. That's what a straight angle is. It's a 180 degree angle. It is a line. So if you were to draw that on your own paper, it's just like that. The last thing we're going to talk about is the angle addition postulate. I want to start off by naming all of the angles that are in this picture. Okay, I see one that goes from right here up like that. Okay, that would be angle AOB. I see another one that goes down like that and then over. That could be angle BOC. And then I see one more that goes from right there and it goes over that way. That angle would be AOC. Okay, for all of those that I just named off, you can swap them around. You could have BOA, COB, and COA. All of those would be good answers. But what I'm getting at here is that when you first look at that picture, it looks like there's only 2 angles. But there's actually 3 when you include the whole thing going from right here all the way over to here. Okay? So the segment addition postulate is this. If you take the measures of these 2 smaller angles, this measurement right here and this measurement right here, you can add those together and get the whole entire thing. Okay? This right here that just popped up, that is the algebraic expression that goes in your notes. Okay? That is the algebraic fancy math symbols version of saying the 2 smaller angles make up the larger angle. So this is just like what we talked about with segment addition. With segment addition, we talked about how the 2 smaller chunks of, if you have a line segment that's split into pieces, you can add together the length of those pieces to get the length of the entire thing. Okay? Angle measures work exactly the same way. Angle measures work exactly the same way. You can take the smaller angle measures and add them together and end up with the measure of the entire larger angle. We have one example problem that goes with this. Okay, we start off just like we did before, naming the three angles in that figure. We've got RQS, we've got SQT, and we've got RQT. And if we have those three angles, we have a little bit more information that's also given to us. It tells us that RQT, the largest angle that goes across right there, it tells us that that measure is 155. Okay, and then it asks us to find the two smaller angles. So if we're going to do that, we have to use angle addition. Angle addition says that if we take these two chunks, 4x minus 20 and 3x plus 14, and we add them together, that'll equal the measure of the entire thing. When we substitute the information, that's what it is. 4x minus 20, 3x plus 14, all added together equals the whole thing, 155. To solve this equation, we got to combine like terms. I see 4x and 3x. I see minus 20 and plus 14. Combined all together is 7x minus 6. Up next, we have to treat it like the house party, right? X is throwing a house party, and at the end of the party, the friends go home first. Okay, so we got to get rid of that minus 6, and we add 6 on both sides. That right there is equal to 161. Up next, we got to send the family members home. All right, the things that the numbers that X is closest to, its family members. We have to get rid of that 7, so we divide it out. 161 divided by 7 actually ends up dividing evenly. It's 23. The question, are we finished with the problem at this point? We found X equals. Are we done? And the answer is no. We're not done because the question itself wasn't asking about X. The question was asking, what's the measure of those two angles? The question doesn't care what X is. The question wants to know what's going on with those angles. And so to find that, we have to plug X into those two expressions. All right, 4x minus 20 and 3x plus 14 becomes 4 times 23 minus 20. 3 times 23 plus 14. We end up with 72 and 83. When you take the quiz and the test, you'll be allowed to use calculators. I don't want y'all to mess up these numbers. I don't want y'all to get wrong answers just because you messed up the numbers, okay? I'm testing you're testing your geometry skills, not your number skills here. All right? So we end up with those two answers. If we weren't sure about those, to check our work, we can just add them together. If we add these two things together and it equals 155, then we are all set. We know we did a good job. And look at that. It's exactly what it's equal to. All right. So that is the end of this lesson. We will be all set to go after this one. Make sure you answer the questions in the left margin and complete the summary, and we'll be good. That's all we got. Appreciate it.